So this problem here, when I look at this light problem, so we got a street light, casts a shadow, the man's 2 meters tall, the street light 6 meters. This man is 5 meters from the street light and he casts a shadow of unknown length. So we're going to just call this unknown length x, and we need to understand what's the relationship here. How is this problem? What's the relationship in this problem? And what we want to try to recognize is that there are some similar triangles involved. So there's this big triangle and this small triangle, and they are similar triangles. And similar triangles are related by proportionality. So I'm going to compare this big triangle here to this smaller triangle in here, okay, and say that they are proportional to each other. And so to do that, then I need to set up a ratio, proportional ratio. And so what I'm going to set up is my horizontal to my vertical as a ratio, and I know that's equal to 5 plus x to 6. That's my big triangle. Okay, then I need to set up the same proportion in the little triangle. Well, it's my horizontal to vertical, so my horizontal is x. My vertical is 2 meters, and that's my small triangle relationship. Okay, my small triangle proportion, we know that they're proportionally the same. They're different in size, but they're proportionally the same. So then I can solve this by getting rid of the time, divide by 6, divide by 2, by times 6. So I get 5 plus x is equal to the divide 2 times 2 cancel out. I'm just left with times 3. And there it is. So I end up with solving this. I end up with 2x equals 5. And I guess x is equal to 2.5 meters. So that's the length of this shadow. So the key is to recognize the relationship, understand the math of the relationship is this proportionality. So in this one here, it's the same thing. These are similar triangles. We have 3 triangles and they're all similar to each other, so the math involved is proportionality. Okay, so this is not an easy problem to do, actually. So if you're finding this hard to kind of look at and see, we need a little bit of practice in this, but we need to be able to set up a ratio here. And we have 2 unknowns, so we need to set up 2 relationships. So one thing I can do is I can set up a proportional relationship for 2 different triangles. So I'm going to use this medium-sized triangle here, and I'm going to use the big triangle out here. Okay, so I'm going to try to set up a relationship here, and my relationship here is going to be, well, I can say the hypotenuse to the horizontal side. Okay, so the hypotenuse to the, we'll call side A. We'll call that side A. It's going to be 8 to y, and this is in the yellow triangle. Okay, and then I can set up the same proportion, the hypotenuse to the horizontal side. We'll call A. So that's going to be now 8. Now the hypotenuse that's going to be hard because I don't want to use y. And in fact, I don't need to use y because this is a right triangle. So if I know 2 sides of a right triangle, I know that this whole length here is going to be 10. So I can say that the horizontal to the hypotenuse is 8 to 10. Or this kind of side, this side here, we'll call A to the hypotenuse is going to be y to 8. Okay, so there's my relationship, and that's going to allow me to solve for y. So when I solve for y here, I'm just going to cross multiply this one. I get 64 equals 10y. So I end up with y equals 6.4. Okay, and I can use Pythagoras to solve for x, but I'm going to actually use that same proportion. Okay, I'm going to use that 10 to 8 proportion. Okay, and I'm going to use that to solve for this. Use this smaller triangle here, the small triangle, and set up the same thing. So the hypotenuse to that side A, so hypotenuse is 6. To the side A is going to be x. That's going to be the bottom of that right triangle. It's going to be the same as the hypotenuse 10 to the bottom 8. And cross multiplying here, I get x is equal to 4.8. Okay, so those are my two lengths. And again, the key here is recognizing the proportionality, being able to organize it to be able to set up the proportion or ratio correctly, recognizing that we could use Pythagoras here to help us out.